Welcome back. We're in section F of chapter 18, integrating f of ax plus b. So now the functions are looking a little more complicated. So here's some basic rules for us. And as you can see, these rules are listed on page 463, okay, in this chart. Very important to take a look at. Also in your formula booklet, you'll be seeing some of this. So back to integrating this first one. The integral of e to the power of ax plus b dx. Okay, so before, let's just think back, when we just had the integral of e to the x dx, that was equal to e to the x and plus our constant of integration c. Okay, now we have something more complicated in our exponent. Okay, so ax plus b. So we've got something more complicated in our exponent. That is going to be equal to that exact e and exponent plus it has to be multiplied by 1 over a. Okay, and then our constant of integration. Okay, so we're multiplying that by 1 over a. We do it exactly like we would do it here, up above with our simple one, but then, and keeping our exponent as the exponent over here, okay, as this exponent, but then we may need to multiply by 1 over a because of this a here. Similarly, I guess we should do an example. So example. The integral of e to the power of 2x plus 1 dx would actually be equal to e to the power of 2x plus 1, but multiplied by 1/2, and then the constant of integration. So you can see what that looks like. Secondly, the simplified version of the second one would be the integral of x to the power of n dx. And remember, we took the power of n, added 1 to it, and then divided by that bigger exponent, and then we had our constant of integration. Okay, so we're basically going to do that exact same thing, but we have, it's not just an x, it's an ax plus b in its place, and we're going to need to multiply by 1 over a again. So the integral of ax plus b to power of n dx. Okay, so it follows these same sort of procedures as up here, except for multiplying by 1 over a. So instead of an x here, we have ax plus b. And the exponent remains the same. What we're dividing by remains the same down here. We still have our constant of integration, but we need to multiply by 1 over a. And I need a bit more room here. We need to multiply by 1 over a. So for example, we could have the integral of 3x plus 5 to the power of 2 dx. Okay, now we said last time that we would need to, we don't have a product rule, so we would need to multiply that out. Okay, so now we have a way of dealing with this. So we would have 3x plus 5, increase the exponent by 1 and divide by that number, but also divide by 1 over a, and our a value is 3. Constant of integration, so this would be 3x plus 5 cubed all over 9 plus c. Okay, the next one, we're looking at, we have our x in the denominator. Okay, so the simplified version of this one was 1 over x dx And that just equaled ln absolute value of x, and then our constant of integration. Okay, remember the reason for this is we cannot use our normal rule of adding 1 to the exponent because that exponent is already -1. If we add 1, it'll be 0, and then when we divide by that 0, that's impossible. So here we have a more complicated version of this. And so we do the same thing, but it's not an x, it's an ax plus b. And we multiply by the 1 over a and have our constant of integration. An example. The integral of 1 over 3x plus 2 dx would equal, we need to multiply by 1 over a, so that would be 1 over 3. We take the ln of the absolute value of that 3x plus 2, and we have our constant of integration. And lastly, our trig, cos and sine. Again, same thing is going to happen. Notice that a cannot be equal to 0. Okay, for both of these. For all of these, a cannot be equal to 0. So here we have cos of x. The derivative of that would be, the integral of that would be sine of x. But we don't have x, we have ax plus b, and we multiply by the 1 over a. And have our constant of integration. Likewise, we've got sine of this. The integral of that is negative cos of that number, multiply by the 1 over a, and put in our constant of integration. And remember, these are on page 463.